All right, welcome. Let me start with just telling you, in 2019, I worked with ISV customers on their SaaS applications and trying to modernize them. My co-presenter, Sanjay, he currently works on a team called the AML team, or the Application Modernization Lab team, and he works with our corporate customers, helping them modernize their applications. And one of the things we found in common was a lot of times it's hard to figure out what a modern application is, or as we look, there's not a lot of resources for greenfield builds of .NET applications in a modern design. And so that's how we came up with cloud-native .NET applications on AWS. Hopefully you'll enjoy it today. We are going to start by talking about modernization in general. So we're going to start at the top and then get deeper and deeper as we go. I think it's going to fit everybody in the room. Hopefully, my goal is everybody is going to leave here today with learning something. And so we talked with Victor earlier. Victor, thank you for your information. I wanted to call you out and say how good it was talking to you about Visual Basic.NET and your programming there. We're going to go deep into .NET, C# and that kind of stuff towards the end. But we'll start with just what and why to build a modern app in the first place. As we get going, why build modern applications? So it's business reasons, right? It's always business reasons. Our business reasons, Sanjay and we built a modern app that's for you guys here. And the reason we built it was two business reasons. One, it was cool, and we wanted to learn the new cutting edge stuff. I was about to use a different technical term. I should go with stuff. The other thing is we wanted to help everybody learn about it, right? So that's our business reasons. Your business reasons are going to be, bigger, better, faster, stronger, less expensive, whatever that might be. And that's why we build modern apps, right? Is for business or because it's cool, one of the two. My favorite customer example that showcases a modern app is Netflix. Now, our modern app is serverless and it's very different than the Netflix design. But I just wanted to point out how you can identify it, because I know it when I see it, and this is definitely a modern app because, for example, on Friday evening, at peak, they're pushing out from one of our customers 1/3 of all the internet traffic in the United States. Pretty darn impressive, right? That is scalable, right? If we look at deployment, if we look at time to market, business agility, they're deploying thousands of new versions in a day, in one day. And traditionally, what we do, one push a year, two pushes a year maybe if we're aggressive. So that is another aspect of modern apps, and that is another reason why this is really cool. And then lastly, something that they do that our app does not do is they do a self-healing chaos design. And they have a service called Chaos Monkey, and they have a service called Chaos Kong and Chaos Gorilla that deletes servers, it deletes load balancers, it deletes whole regions, and in production to watch that, to make sure their app self-heals itself. And you can search this stuff online and read about it. It's really cool. But I wanted to call that out just because this is definitely a modern app. It's hard to define a modern app. We have a definition on the Amazon website. I'm not sure I totally can read that definition and recognize a modern app necessarily. So we came up with these 8 characteristics of a modern app. But still, by the end of this session, I hope I'm going to get all of you to be able to recognize a modern app when you see it. Can you guys recognize one today? Sanjay, can you tell us what a modern app is and how to recognize it today?
Yeah, Brian, that's really an interesting question, right? So we kind of struggled initially defining what the modern app is, right? And then we started to look at, let's see how AWS defines a modern app, as you're saying, right? So the way AWS defines it, it's a combination of multiple things, right? It's a combination of modern architecture, modern technologies, delivery practices, and deployment processes, right? So all combined define that as a modern app. And as we work with the customer, and we also see typically a modern app take benefits of loosely coupled, event-driven, serverless technologies that offload the undifferentiated effort that customers has to do to provide a value back to their team, right? Or value back to the customer. So knowing all of that, we came up with these 8 characteristics as how would you define a modern app, right? And going back to the example, Brian, you're talking about Netflix, right? As they were talking about, they shut down the servers in the middle of a day. For them, the business reason is high availability, right? And that's how like we have one of the characteristics about fault tolerant and resiliency. And if you're looking to build an application that is highly scalable and for agility, you want to look into building a more for microservices and have it being able to deploy with its own CI/CD pipeline, right? So these are the characteristics that you want to look into building a modern app. But there's other sides too, right? As you see on the screen, we have the characteristics for the backend application. We also have the front end, right? So you have to look at both sides of the application to build a modern app. So when you look at the front end, the business case might be to be able to have your front-end application run into maybe into web browser, or maybe able to run this into a mobile app or a streaming game, right? So you want to look into building the modern UI that can scale globally and could be able to run to multiple platforms. And also you have to look at your back-end architecture to be able to scale, to be able to fault tolerant and have it connected through an API to give its scalability part of it, right? So those all kind of become the part of a modern app.
So before we go into, and we're gonna show you this app, but what we want to do is show you the front end and some of that stuff, and we're gonna show you what we built, and then we're gonna go later into the back end of how we built it and all the different things that we uncovered and some of that stuff, and get deeper into the .NET aspect of it.
Yeah, and going back to the modern app, right, as we talk about identifying a modern app, right? And that's the other reason we build this reference architecture, to have the discussion with the customer about what a modern app looks like, right? Here, as you see on the screen, we have like a modern UI that is built using Blazor, right? And for the folks who are not familiar with the Blazor, Blazor essentially is a new web technology released by Microsoft to be able to build the interactive client UI using C# instead of using JavaScript, right? As we typically use Angular, React, or Vue.js to build your UI application, right? Here you can actually use C# to build your front end. And on the mid, you see the solution file. That's essentially all your backend application with all the different components that are completely loosely coupled. There are multiple ways to organize your code, right? This is the one way that we have done where I was a single developer. So I put all these different components in a single solution file. But let's say if you have a teams that are, distributed team working on different microservices, you can have different solutions for your different microservices, right? And then the third screenshot you see is the CI/CD pipeline, as we talked about, being able to deliver your code on the agility side. So we have a full CI/CD pipeline to be able to deploy your code from there.
Yeah, and let me issue my disclaimer that I forgot to, which is this is one way to build an app. There's other ways to build it that are just great, right? We look at the different technologies and you choose them based on business needs, and sometimes you choose them just on what's cool or something else. So there's obviously other ways to do this. So we're not saying this is the only way, right? There's all kinds of right ways. There are wrong ways, right? Things that don't work and are horribly wrong, but there's no right way. This is one way. And as you switch over to the demo.
Yeah, let's go to the demo, right? So let's go into demo and see how this app look like.
And as he switches to that, I just want to mention on the code pipeline, we deploy this with CloudFormation templates, and then the code build kicks off, grabs the code, and creates the executables and sends them out there. So it takes 35, 40 minutes to build, but it's a really simple install. And so I expect all the developers in here definitely to install this. And anybody who's not a developer, you should install it too and play around with it. It's a great understanding of best practice for code pipeline. It's a great understanding of best practices in coding. You can use it as a straw application or a understanding of how to integrate for your authentication or other aspects, hitting and storing in DynamoDB data from your .NET.
Yeah, so let's look at this in action now. So the whole source code for this serverless application is available online. It's under AWS samples. It's a public repo. Don't worry about the URL as of now. At the end of the slide, we'll have a QR code for everybody to scan the code and grab the URL, right? So we'll have that at the end, so please make sure you have your cameras ready at that. But the whole source code is available. In the application, here are all the components that we're talking about. These are all the loosely coupled components that get deployed when they change, right? And also, if I go back onto this README file, if you scroll down, we have the whole architecture diagram, and we'll go deeper into the architecture diagram as we go into session. But the main thing I want to talk about here is how easy it is to deploy this app, right? So essentially, what you can do is you can fork this code on your own GitHub account. Like once you have a GitHub account, you can go and fork this code, and then you need to create your personal access token. And the reason for creating a personal access token is so the CI/CD pipeline has access to get your code and do a build, right? So once you fork the code and you have the token, then essentially you can just click on launch stack, and that will actually launch the stack into your own AWS account, right? If you're logged in, it will take you right to the CloudFormation, and you'll be able to deploy this CloudFormation stack, right? And if you hit next, there's a couple of details you have to add in, right? Here is your personal access token that you will have to put, and then when you hit next, it will start deploying your application, right? It will do the whole CI/CD pipeline. And as Brian mentioned, it's going to take around 30 to 35 minutes for it to deploy. So I'll not go into the whole deployment process, but I'll show you what it looks like when it's deployed.
I said 35 to 40.
That's more accurate than what I said. I think 35, 40 is right. So essentially, once you have this application deployed, if you go into CloudFormation, right, and as we talk about decoupled architecture, we talk about loosely coupling things, right? That's essentially what this architecture is representing. It is representing these different components that are deployed by its own stack, right? Here you will see we have an APIs, step functions, other functions that are getting deployed. But essentially, that's what you will see once it's all deployed, right? The other thing that we have here is we're using parameter store pretty heavily. So this is like a centralized configuration place where all the configuration for this application is stored, and that is how these multiple components are reading the configuration to know where is the endpoint for API, right? That when the Blazor app is running, it needs to know where's my endpoint for it to connect, right? How these things connect through it. This is the centralized configuration place.
And it's free. No charge for parameter store.
Right, so essentially what you need to do is, once you get here, you need to search for the domain. Essentially, it's your CloudFront URL, and this is where your application is deployed. So let's see how the app looks like from the UI perspective. So once you get to the app, this is, as we talked about, it's built using Blazor, right? And as you will typically see in more of the enterprise applications, they will have an authentication baked into it. So this has the full-blown authentication built into it. This is, here we're using Cognito to authenticate, right? It's like a OIDC authentication where you can sign up as a new user, or if you have a user, you can just log in. Here, I'm just going to use the account I already have built. All right. And once you're logged in, you will see you are successfully logged in here. And what essentially this app is, it's like an image recognition app, right? Where you can create an album and upload the photos to your album, right? So once you're logged in, you can go to albums, create a new album. Here, I already have an album created for XNT402, but you can create more albums. And once you go to an album, if you have any photos, it will show your photos already loaded into this. You'll see a thumbnail and the object detected into the photo, right? So let's see how uploading a photos process look like. Here, I'm going to choose one of the Brian's photo and upload it here. So essentially, what it's going to do is this application is going to take this photo and upload to an S3 bucket, and then it's going to process this photo in the backend. Like it's going to go identify what objects it has and creates a thumbnail and send the information back, right?
And one thing you might not have noticed, did you see how long it took that to load when it did that? That was a cold start. That was with things not loaded in Lambda yet. We'll do another one here with a warm start, and look how fast it goes.
Yeah, and other
right?
thing
See the difference in speed?
Exactly, right? And the other thing I wanted to bring it into attention is as I was uploading this photo, you were seeing the feedback that was coming back, right? The extracted metadata and the photo is successfully created and stuff like that. So essentially, it is using a two-way communication using WebSocket. It's sending the information back to the UI, so it becomes a modern UI. You're not hard refreshing the page. You're getting the UI component back into this, right? So as we talk about both sides, the modern UI and a modern backend with the whole CI/CD pipeline, right? That's what this app is. So essentially, it gives all the best practices of how to use multiple AWS services also. All right, with that, let's go back to our presentation.
Okay, so what we just looked at was a bunch of AWS technologies that we went through, as well as a bunch of just technologies in general, right? So we've got modern app design, we've got WebSockets, CI/CD best practice type stuff. We've got Blazor, Microsoft Blazor, which is the GUI, and we'll talk a lot more about that. So there's a lot to learn here, how to integrate best practice to call and store stuff in Dynamo or S3 or have that kick off Lambda function. So lots of cool things to look at and learn.
So those were the technologies that were used to build this application, right? So here are some of the tools that we used to accelerate our development and deployment processes here, right? So the first tool we use is AWS Toolkit for Visual Studio. And if you guys have not used this tool, in my opinion, it's a must-have tool as you start to build this modern application using AWS Cloud Native Services. And essentially what it is it's just a plugin that you can download from a marketplace in your Visual Studio. And once you have the plugin installed, it gives you the access to these templates that you can use to build a Lambda function or a serverless application or to build a native AOT application, right? So all the templates are there that gives you a kickstart. It has all the boilerplate code that is ready for you to go, and now you can add your business code in there to get the application working, right? Also, what the AWS Toolkit for Visual Studio does is it allows you to deploy your application right into the cloud as you're developing it, right? Because as sometimes I'm developing the code, I want to see how it would work when I deploy it. So right from AWS Toolkit from Visual Studio, within your Visual Studio, I can right-click and deploy my Lambda function and stuff right into the cloud and test it.
You can, but I do want to point out that's not what we're doing in our app.
Well, that is for your development side of it, right? Now, when we go to CI/CD pipeline, it becomes different, but as a part of your development, you can definitely use that, right?
In our app, just to make sure it's clear, when you get and change code and hit commit, it recompiles the app and deploys it live in production. So it's fun to play with.
Yeah, definitely. I think when you go to the CI/CD pipeline, you want to start looking into other tools that I'll just talk about. But one more thing that I want to attention in here is like AWS Toolkit also provides you a very quick and easy way for you to access your AWS services. Let's say if you want to create a new DynamoDB table, or you want to upload a photo to an S3 bucket, everything comes right from the AWS Toolkit right in your Visual Studio, right? So the next tool is AWS Extensions for .NET CLI. It's a tool that can help you to deploy your application, right, as we're talking about the CI/CD pipeline, right? So AWS Toolkit for Visual Studio use AWS Extensions for .NET CLI to actually deploy your application. So it becomes like an easy way for you to transition from your AWS Toolkit to your command prompt, right? You can run the same commands that AWS Toolkit is using from your command prompt and use that commands run into your CI/CD pipeline, right? So that becomes your transitions from Toolkit to your CI/CD processes. And the last tool that we use in this one is the mock Lambda test tools. What essentially it allows you to do, it allows you to test your Lambda functions right from your Visual Studio, right? Like as you're just normal testing your .NET application, where I hit F5 in your Visual Studio, it bring up the debugger and you can debug your code. Exactly what the Lambda tools will do, it will allow you to debug your Lambda function, your business logic, right from your Visual Studio. So great tools to look into. I totally recommend going to and start using this if you start to build a modern application there.
All right, let's talk about architecture. So you saw this a little bit on the GitHub site, but this is the architecture that we designed as we went to go build a modern app. What we did is we looked at, let's do serverless. Let's do some pieces that are dynamic, like, well, Blazor, for example. Let's do that because it's Microsoft C#. And Blazor is cutting edge, and some of the other stuff we're doing with, we'll talk about AOT, that's a bit cutting edge. But what we have here in this architecture, as I walk from the computer on the left side of the screen, right, it first pulls files down from basically a web server, but that's files hosted in an S3 bucket that are static files. It pulls that down to CloudFront, and then CloudFront has an SSL connection to the browser, and then those files go down from CloudFront to the browser. And CloudFront is a worldwide service, so it can scale globally and make that low latency to load that up pretty good. Once the files are on your browser, then you actually hit API Gateway to see what you should load, what you should look at, whatever. And the first thing it does, it says, hey, you're not authenticated. Let's talk to Cognito and have you authenticate against the Cognito database. That then, once you're authenticated, you're able to create the list what's out there. You're able to create albums. And then once you upload an S3 file, or a file to S3, sorry, you upload a picture to S3, that then goes in that bucket and triggers the Lambda step functions.
Yeah, and as I was showing you in the UI demo, right, when I upload the photo, it goes to an S3 bucket, right? And what it does is it creates an event that our step functions are kind of listening to, right? Or the Lambda function that get triggered, that's getting that event, and then this Lambda function is triggering a step function, right? So the backend logic of extracting the metadata or creating a thumbnail and talking to image recognition API to find the object, that is all running through the step function. And in the end, it stores all that metadata into a DynamoDB table, which we have it front by an API gateway, as Brian, you're talking about, the services we have that the UI is using to get the albums, to get the photos, right? And also this backend system that we have for the step function, it also sends this two-way notification using WebSockets to tell UI, okay, this step is successful, and those kind of things is already baked into this backend system here.
So this is written in .NET 7. .NET 7 shipped November 8th, so just 3 weeks or so ago. We had it previously in .NET 6, And on the Blazor side, there was some problems with libraries for encryption, right? They weren't there. And so we had to put Blazor on the server as opposed to Blazor in the browser. We'll go more into that in depth in a little bit, but we were able to move to Blazor in the browser, which reduced our costs from about $50 a month for this app to it's 100% in the free tier, at least for your first 100,000 photos that you upload. If it's not in the free tier or you're beyond that, your next 100,000 photos will still, as you work within there, it'll be under $10 a month. So that's one of the reasons I really like this type of architecture is because when nothing's going on, the cost is next to nothing, right? You've got S3 storage and your DynamoDB storage. When things are going on, you've got Lambda functions that run, and even there, it's really inexpensive. And so, again, it's for 100,000 pictures or say 100,000 users all uploading one photo, it's still under $10 for that. So that's for 1 million invocations of Lambda.
Exactly. And another cool thing that I like about this architecture as we're building towards it, right? We talk about resiliency and a fault tolerance, right? So those things are baked into it. Right? As you start using a Lambda function, you can retry your Lambda function. If there's an exception happen, that's already baked into it. And if it throws an error after retrying, you can put the item into a dead letter queue, right? So that you don't lose an event, that's also baked into it. The same thing goes into a step function, as if the step function kind of throws an error, you can put an item into a dead letter queue, right? So you get all the resiliency and fault tolerant baked into this architecture. You start using the serverless technologies, right? And other great thing about this one, Brian, as we were talking about, right, containers versus servers, right? Then when you start to look into multiple AZs, right? Now you have to say, okay, if I'm putting all the containers in one AZ and I have to distribute across multiple AZs to get highly availability. But as you start using these more serverless technologies, right, using Lambdas and S3 buckets, it's already a regional services, right? We don't have to design for going multi-AZs. The S3 or the Lambda function gives us that out of the box. Like step function is a regional service, right? Cognito is a regional service. So that kind of thing, like I start using the services, getting this benefits out of the box, is really a great value to get into.
Yeah, that fault tolerance is automatically there, right? That's awesome. So we don't have to do anything to get that multi-AZ, like you were saying.
Exactly.
All right, let's move on and focus in a little bit on the front-end architecture.
Yeah, so as we talked about this best practices of application, right? And I was talking about talking about both front end and back end, right? So let's take a look at a front end, right? So essentially, there's multiple ways to build the front end. Here we chose to build it like a single page application. And so for the folks, essentially what single page application means, essentially it's a browser application where you're, essentially it's a web browser application where it downloads a single page and then all the client UI logic is running in the browser, right? So if it needs any dynamic content, we'll make an API call, get the content, and dynamically change the UI based on the user interaction, right? And the benefit of that one is, right, so you don't have to run any servers on the back end, right? As in the traditional .NET application, where if you're running, MVC application on the web forms, you're running these back-end applications or back-end servers that renders your HTML and send HTML back, right? But as you go towards more of a single-page application, your application could scale better, right? We don't run these back-end servers to scale your UI at that point, right? And also, I guess the second best practice is cross-platform. That goes back to the business needs, right? Typically, when we look into modern app, customers would like to build an application that could be cross-platform. And with the cross-platform, we mean is to have different UIs, right? If you want to run into maybe like a browser, you want to run a mobile app, you want to run the same UI component into the desktop application, right? So you want to build a UI that is cross-platform and could share the same UI components, right?
And we actually went with not the traditional JavaScript stuff, right? We went with Blazor. And Blazor, well, we'll talk about it on the next screen a little bit. Right. It's got some really great cross-platform
Exactly,
pieces.
But I think last thing we want to talk on this one is the OIDC authentication, right? As we start talking about this multiple platform, we do really want to make sure our authentication is cross-platform, right? We want to be able to say, okay, now if we're using from browsers going to a mobile app, we don't want to rebuild all those things that we've done with the OIDC side, right? So essentially what OIDC allows is it allows you to identify the user based on this trusted authorization server, and it gives you back a JOT token, right? And the JOT token is kind of cryptographically signed that allows you to be more secure as it avoids the man-in-the-middle attack, right? So that's the best way of doing cross-platform applications using OIDC authentication. So that kind of becomes the characteristics of building a modern app, right? So going into what you were saying, Brian.
We were going with Blazor, right? And Blazor runs on the browser now in WebAssembly. So if you haven't seen WebAssembly or WASM, Can you tell us what
Yeah.
WASM is and how it works?
Yeah, well, I think essentially just touching on the Blazor a little bit, right? So as you're saying, Brian, Blazor could be run in the browser. So it's using WebAssemblies. What WebAssembly is essentially is a low-level bytecode that all the modern browsers understand, right? Essentially what it means is like if you can, let's say if you have a code that's written in any language, and if you can compile that to WebAssembly, then you can run that code in the browser using WebAssemblies, right? And that's essentially what Dotnet has done, Microsoft has done that way. So they have built the Dotnet runtime on top of WebAssemblies, right? That allows us to do is I can take any .NET intermediate language assembly and I can run that in the browser because .NET runtime will combine into WebAssembly and now it can run on the browser, right? That's essentially what Blazor on the browser does. And
are there any downsides to that?
There's always something to talk about, right? So, well, I think there are definitely some downsides to it, right? One of the downsides is your size of your application, right? As we're talking about .NET runtime getting downloaded in the browser, we're talking about your assemblies getting downloaded in the browser. So you might see like a slow startup time, right? Where your assemblies are getting downloaded, but once it's downloaded and specifically as we're using CloudFront, right? That get cached at all the different nodes, so that helps, but we definitely have to be very careful about the size of the application that's getting downloaded.
You saw that in our app, actually, as it first brought up. There's that little circle that went. That's Microsoft's Blazor as it downloads the things. It lasted about a quarter of a second in this application.
Yeah. So definitely there's stuff that we have to look around. Like we don't want to be making heavy DLLs to be used in the browser, as that could affect the performance of the app, right? But
what about the positive things it adds?
Exactly, right? That's exactly the Blazor hybrid come along, and we talk about cross-platform, right? So Blazor is a new direction, essentially is a direction from the Microsoft to build your modern UI applications, because now you can run in the web browser, as we're talking about the WebAssembly. And with the .NET 6, we're running the same Blazor code in the containers, right? So you can run in the browser, you can run the container on the server side. The cool thing about Blazor is you can use Blazor hybrid to be able to run the same UI components into your mobile apps, like native mobile apps, that is using a MAUI framework, right? Essentially, MAUI is a cross-platform framework from Microsoft, and using that, I can run the same Blazor UI components in your native application. That gives you cross-platform going from your web browsers into the native apps, right?
All right, the other thing I'm thinking about is this is, a little bit cutting edge still in Blazor. Did we run into any problems maybe with OIDC, with OpenID Connect?
Yeah. So essentially, the third point here is like about OIDC, right? As you said, it's a cross-cutting edge, right? So Blazor behind the scene uses silent authentication to authenticate the user. And as we were looking into integrating with the Cognito, we found Cognito does not have a silent authentication feature baked into it yet. And then what we've done is we've created a kind of a shim or a kind of proxy for our Cognito that kind of look at if there is a request coming for silent authentication, and we just redirect with the 404 to tell customer to go to the authentication screen, like go right to the screen where they can put the username and password, right? And if you don't do that, you will probably see a 10-second delay in your application where it's trying to time out. But with the shim or with this proxy, it gives you the nice integration with Cognito. So that's the way that we build Blazor for us to be able to use the modern application here.
All right, so that's the front end. Hopefully that's helpful. We're going to go into the back end architecture now. So,
yeah, so this actually kind of reminds me, as we work with a customer, right? One of the repeatable pattern that we see with a lot of customers where they will have a Windows service that will be running in one of the application servers, right? That will be constantly polling the table in their application, right? It will keep looking for, do I have any work to do, right? If there is some work, they will process the work. If there is nothing, we'll just constantly keep polling, right?
Anybody else have that? Anybody got tables that they're polling with their stuff? All right, I saw about 5 hands and 6 hands. The rest of you are either sleeping or lying.
But that does become the challenge, right? Because as you have this Windows services kind of thing that's polling your application, it's kind of hard to scale those kind of architecture, right? Now, let's say if you have to scale your Windows services horizontally, now you have to kind of worry about concurrency of your Windows services, right? We don't want 2 Windows services picking the same item and acting on it. And we want to make sure it's, you're able to scale as the load coming into your queue, right? A single Windows service, how much work it can take, maybe multi-threading, but still have the problem of scalability, right? So you have to be careful about how you expand your applications and make them more scalable, right? So in this architecture here, what we've done is we have kind of built more of an event-driven architecture, where the files are getting dropped into the S3 bucket. That kind of triggers the Lambda function that completely scales horizontally, right? We don't have to worry about concurrency here because Lambda function would just scale as new events are coming into system. And when this comes in, it will trigger a new step function that will also scale horizontally. For every new execution, it will just start a new step function to execute, right? And going back on the customer example where we're just running a Windows service, right? So essentially, what we came up with, like on that one, is to instead of using the queues in the table, right? You can use SQS queues or queue that can handle, this concurrency kind of issues, right? The way our SQS handles it, it has this visibility timeout, right? So if somebody picks an item, it just have a timeout, so it will not be visible for the next item to be picked up. So that kind of solves the problem of concurrency because one will pick the item, right? And then if you're using kind of Lambda function, it allows you to scale your application horizontally, right? So that gives you like an event-driven and scalability kind of architecture that you want to be built into your application. Also resiliency and fault tolerance that we kind of talked about that already, where the system has the retries baked into it, as the Lambda function has retries baked into it. If it has a problem, then it has this dead letter queue where it will move the item in there so that you don't lose the event that comes in, right? And security, I think it's completely baked in. It's like it's a job zero, right?
Not completely baked in. You still got to do your job, but there's a lot of security in default in this, right? You don't have servers to patch. You don't have access to those servers. You still have to watch your name and password, right? You use the word password, you're going to get owned.
Right.
But there is inherently in this the files that are being served down by the web browser. There's no access to them. They're static files, right? So there's some good security there. The way to hack into this, if you're a hacker, is you go after the account, right? So they use multi-factor authentication because that's where the hackers are going to have to go to get into this app.
Yeah, and just talking about the IAM rules, I was thinking about from the Lambda perspective, from the security, right? These Lambda functions are running a specific IAM rule that only gives a permission to what it needs to do, right? So those security is already is kind of part of the application here, right? So now let's talk about building backend applications with .NET 7.
Yep, we're going to spend some time on this slide and on these 3 bullet points because there's just a ton we learned about .NET 7, right? It's been GA for 3 weeks or so, but there's a lot of differences. There's some really great stuff. There's really some hurdles we hit as well. First, let's talk about .NET 7. It's an STS version, right? So this is the .NET Core stuff. It's cross-platform, but they don't use the word core anymore, right? Core is no longer used. But 6 is a long-term support. 7 is not short-term, standard-term support. Long-term support is 3 years. Standard-term support is 1.5 years, right? And what AWS does with standard-term support is we don't build a custom runtime for it, right?
Managed runtime.
A managed runtime, I'm sorry. A managed runtime. We do for 6. So 6 has a managed runtime, 7 does not. And so we've got 2 choices there.
Yeah, so as Brian mentioned, right, for .NET 7, we don't have a managed runtime, but we still have 2 ways to run your .NET 7 application, right? As we start talking about native AOT, and we start talking about just running a .NET application, right? So the first way you can do is you can use a Lambda container images that you can build your application as a container image, and you deploy your Lambda as a container. And the second option is you build your application as a native AOT app, right? And using a native AOT, you can run your .NET 7 Lambda functions using a custom runtime. So those are the 2 ways that you can build your .NET 7 applications.
And let's talk about native AOT for a second, because that's what our app uses on the back end, or for a good portion of it. And there's some really interesting reasons why we went with that. 1 being it's new, but 2 being it's amazingly fast, and we'll get more into that in a second. Right. AOT, though, what does that mean?
Yeah, so essentially what native AOT is, it's a new deployment model released by Microsoft to deploy your .NET application as a single, self-contained single binary application, right? So what essentially it means is it will pre-compile your .NET application into a machine code at the time of publish, right? Which is different than what we are mostly used to, where we'll build application into intermediate language, and then we have just-in-time compiler that will compile your assemblies into the machine code, right? With native AOT, your code is pre-compiled to the machine code at the time of publish. So it's ahead of time compilation instead of a just-in-time compilation, right? And the other thing with the native AOT is it's a self-contained app. So what it means is you don't really need a .NET runtime installed on the server where you're running the code because it's already a self-contained application, right? So those are two main things. It's pre-compiled to your machine code, and it's a self-contained binary, right?
All right, so that sounds good and bad. Why don't we start with what's the bad? What's the downsides of it?
Yeah, so the first challenge that is, as we talk about, right, it is pre-compiled to the machine code, right? The first challenge it comes down to is when it is compiling your application, it is compiling down to your operating system and to your processor architecture, right? So what it means is, let's say if I compile this application on my local machine, which is Windows x86 architecture, then it's going to compile my application to a Windows OS and to the x86 architecture. That means I cannot run this on Linux OS or the different processor, right? So that's the first challenge is you need to know where your code is going to run, and you want to compile your application using that OS and that architecture, right? So example for Lambda, it's running using Amazon Linux 2 machines, and you can use it for x86 and ARM64, but you have to be using those OS and the processor architecture to be able to build and run them into Lambda, right? So that's the first thing. It's not cross-platform. It is specific to the platform we are building into.
Now, when you play with this code, you don't really have to worry about it because the CI/CD pipeline takes your code, puts it in a Amazon 2 Linux, compiles it there, and then pushes it out to the Lambda.
Right.
So it's easy.
Yeah,
commit and done.
Exactly, and also just recently we have also released, as I was talking about the AWS toolkit for Visual Studio, that exactly you have the support for native AOTs too. Like you can publish a native AOT right from your Visual Studio to cloud. It does the same thing. It will spin up a container, build your application using Amazon Linux 2, and you'll be able to deploy that to Linux, right?
Okay, so there's got to be benefits. What are the benefits to AOT?
Well, there are really good benefits of that one, right? As we just talked about, it is compiled to the machine code, right?
Yep.
So you don't need a just-in-time compiler, right? What it helps you do is, now since you're not using a just-in-time compiler, you will see the performance benefit, right? Now as we talk about cold start versus execution time in the Lambda function, right? But if I already have it pre-jet, if it's already compiled to the machine code, I should see a better cold start. I should be seeing a faster cold start.
Yeah.
And I should also be seeing the faster execution time.
Well, we assumed we would see a faster cold start. We figured the runtime, right, would be just about the same, right? It's .NET still, it's the same stuff. So when we took our same code and changed it from our .NET 6 to .NET 7 and .NET 7 AOT, we saw in the cold start a 20 to 80% performance improvement on our cold start, which is pretty good, right? That's great.
Yeah.
And then when we went and looked at the invocation, like at the run, how long it took, the execution time. That execution time, what did that do?
It was 100 to 400%.
200.
In our app,
it was 200 to 400% faster.
Yeah, so that was really
shockingly to us. We didn't expect that at all.
Exactly. That was really, like, we were always thinking of the cold start will be faster, right? Because there's no JIT required. But essentially, your execution time, think of your Lambda is already warm, and most of the time your application is warm when you're taking the request, right? Your execution time is like 200, 400% faster when you go to the native AOT, right?
Our app was.
Oh, right.
Your mileage may vary, but our app was 200 to 400%.
But we have done internal benchmarking. We've done the internal testing, and we actually saw compared to Go and Python, right? So if you're using a similar architecture, we have done some benchmarking internally to see how fast the native AOT is. It goes faster than Go and native AOT, right?
Yeah.
Granted, you're using the same architecture and same code in the different languages, but native AOT has a lot of performance benefits down to it.
That's what we used to recommend, right? When you wanted a really fast startup time and a really fast Lambda execution, we'd say, oh, well, write it in Go or write it in Python, right?
Yeah.
You guys have heard that? Yes, some of you have. Now, going forward, I don't know if we're saying it totally yet, but we will be saying it because AOT is tons faster.
Exactly.
It is the fastest anywhere. So that's kind of nice to know for us .NET developers that we now have the fastest code on the market, right? Yeah. Forget about the Java stuff that we used to compete with. We're competing with Go and Python now.
Yeah, and a couple of things that you still want to be considering about, right, as we talk about some of the challenges, right? I just want to share some of the challenges that we had when we were actually converting our .NET 6 to .NET 7 and then going to native AOT, right? The other challenges that we saw along with compilation thing that we talked about is the trimming that the native AOT does, right? So essentially, what native AOT do is, as I was saying, is a self-contained binary, right? Now think about having a .NET runtime as a part of your executable. It's going to be big, right? So what native AOT does is at the time of compilation, it will trim out the libraries that are not used. So essentially, we'll do a static code analysis and find the assemblies that are actually not used in the application. We'll just remove it. It's not just the assemblies, it will actually go in the code of an assembly that will look at the classes or the methods in the classes that are not used. It will just remove those classes and methods out of your application, and you will only have optimized deployment package, which is great for Lambdas, right? What else you want? Smaller package, pre-compile, it really helps a lot with the native AOT side for Lambda. But a couple of things that you want to keep in mind as it's removing the code from your application. You want to be careful with the reflection, right? If your application is using reflection and it's loading the classes at a runtime and it's executing the methods at a runtime, you want to be careful because it might remove the method that doesn't see the static code analysis for it, right? So you want to make sure you provide enough hints to the compiler to be able to not remove those things, right? But because if you don't do that, it's going to go and do the aggressive trimming and remove your code, right? So we had a similar challenge. I want to show you exactly how we can get around that challenge of trimming, right? So there's a couple of ways we can provide the hint. Let me go back to.
While he goes in, what he's going to demonstrate to you is how to set and take out our extensions, the NuGet packages, right? Not how to take them out, how to prevent them from being trimmed, right? Because if you remove that code, they won't function if they haven't been built for this. And since this just shipped November 8th as a GA type thing, it was test in .NET 6.
So essentially, what I was talking about is providing some hints to the compiler. Oh, here you go. All right, let me just show you quickly. I think
it's going to provide hints to the compiler that tells it, hey, don't trim these things. They don't understand how to trim it.
Yeah, so here is the source code that I've actually cloned on my local machine. This is what you will see once you clone the application and open the Visual Studio. But I'm just going to go use quickly in a step function, which is built using Native AOT. And I'm just going to pick this extract image metadata. One of the functions is a part of a step function. And it's using third parties assemblies right here. Like we're using 6labor.image_sharp. It's one of the assemblies that we're using to extract the metadata and do like creating a thumbnail for your application, right? And it's talking about the native AOT that trims your application. And initially what we showed, our application was not working, right? Because it was kind of removing the code that this assembly relies on, right? So we have to provide the hints to our application to don't trim it. One of the ways you can do is we can add this runtime directives in your application. And here we're telling .NET compiler to not go and trim this assembly, right? We don't want it to trim it. It can trim other assemblies, but not these ones because it's a NuGet package we're using. We don't control the code, and we want to take the whole things in it, right? Have to be careful a little bit because as you add more assemblies, your size of the package will be bigger, and that kind of goes to your cold start, right? It's going to go download the code, right? But that's the one way of doing it. And as we started to look at, right, so the recommendations from Microsoft, there is a latest recommendation that have came from the Microsoft about how they want to approach and move forward. One is to do the RDXML file, but the preferred way of doing that is actually adding a trim mode option. So essentially what you can do is you can add a trim mode here. And there's multiple options in the trim mode. You can add it as a partial, or you can add a full, right? There's two modes in here. If you go full mode, which is the default, so essentially if I don't specify, its default is full. And that is where it's going to go start trimming your assemblies, start trimming your classes, start trimming your methods. But then you will start seeing those runtime errors, right? The other option is what I prefer, and it's really great to get started with, is to specify it as a partial, right? What partial mode does is it essentially does kind of similar thing what RDXML file is doing, but it's doing in a better way, where it is only looking to trim the assemblies that are marked to be trimmable, right? So as you use the NuGet package, which is not trimmable yet, it will not go trim it, right? So this is the way I would recommend to get started, and and then definitely look at the compile errors, because what Microsoft has done is as you compile, and as they see this code that could be trimmable, it will start throwing the warnings for you, right? So you want to look at all the warnings, definitely test your code, but definitely use the partial as a way to go.
So our current code is using the RDXML. As soon as we accept the pull request here, it'll be updated. We didn't test that before this, so we got to do some testing before we go. But it'll be there in the next couple of weeks, and we'll have it updated with that.
Yes, exactly.
We had a call with Microsoft last week where they recommended, because they haven't documented RDXML, so they're like, that's not our preferred way. Our preferred way is this. It's a lot easier for all of us, too. So that's the way to go going forward, and our code will be updated in the next few weeks to have that in it.
Right, so that's definitely the preferred way of doing it, and that allows you to start building a native application and instead of worrying about the assemblies getting trimmed. Unless the assembly is marked as trimmed, it will not trim. With that, let's go back.
Another thing we came across and thought about is we're like, okay, what are the other things going on here? All right, so every month or 2 or 3, whatever, you're seeing a .NET runtime patch that comes down, right? On the second Tuesday of every month, right? And one of the things that we've never worried about with our app, our business app, because it's just-in-time compiled, we never worried about that, right? The OS gets its patches to the runtime, and we're good. Well, now we just bundled the runtime into our app, which means every time the patch comes out for that, you probably need to think about recompiling your app and pushing your app out.
Yeah, making a self-deployable, self-contained app, right?
The self-contained
Your
app,
.NET
with
runtime
AOT.
is part of that one. As the new patch comes in, you have to be, now it becomes a code deploy to patch that thing, right? And also, one more thing was the build time, right? Yes, right? So like before, as we're using a code build to build our application, we're using a small containers to build it. But when you start using Native AOT, as you would imagine, the build is doing more work. It is compiling it to the machine language, right? To machine code. So you want to make sure you have enough processing or enough memory in your build process to be able to build that application. So we actually had to go from small to medium size to be able to see the builds working, right? Let's go.
All right, let's go into a demo of the backend service,
basically
of the step functions. So we're going to look not just at, so there's Lambda functions. We also have step functions of Lambda, and our backend uses step functions.
Yeah, so let's go look into the demo for the backend and see how the backend works. So as we talked about in the architecture diagram, we're using step functions, right? Once the code is deployed, you will see the state machine deployed in your AWS account. And if you click on this, you will see the multiple executions that has been happened to it. As here you can see we have executed multiple images. You will see all of those happening here. You can filter down the status by what failed, whatever was successful, right? You can filter it down to that. But most exciting about this one is as you go into the execution, it shows you the graphical representation of the execution of the flow, right? Here we don't have to write a code for getting this execution. It just came out of the box, right? As you use step function, I can completely see how the flow of my application run, right? You can see I was running some sequential steps. There are some parallel steps happening to create a thumbnail and creating those objects that are being extracted from your application, right? So
oohs and ahs are welcomed and appreciated if you wish here. Kind of cool stuff.
Yeah, another cool things about using a step function is that's really helpful in the debugging and troubleshooting is like getting what's the exact input that was passed to the step function and how the execution process, right? So let's say if I want to know exactly what was the input for my step function, I can come here and see all of that right from the input and output. And also, I can go down and look at every single step, what was the input and what was the output, right? That is really helpful in troubleshooting and debugging the code, what's happening, why it's having a trouble, stuff like that, right? So, and one cool thing about the step function, what it does is it actually persists the state in a JSON format. So everything that's happening in every single function is passed into the next part of it, right? So essentially the output of this function becomes the input for the next function or the next step in the step flow, right? Just one cool thing, as I just want to highlight here, is a dead letter queue. Let's talk about fault tolerance. So if there is any failure, the step function will put the item in a dead letter queue so you don't lose the events, right? And below down, you can see all the events that happen along as the execution of the step function.
Cool.
All right, let's go back to our.
All right, let's talk a little bit about observability. So I've been an infrastructure guy for a good part of my career. How about other people? Any infrastructure guys in here? A bunch of us. All right, cool. So I had been a server hugger for a short period of time anyway, because these serverless apps can't show us as much, right? You would think as going into the processes of looking at how much RAM's being used, look at the CPU usage on your server. When I'm working in my server, I know everything, right? I have logs. Wow. We're using X-ray here, and we're going to go and show you what X-ray is, but wow, does X-ray give us insight way beyond what we've ever had.
Yeah, and that's actually is a very, very common ask from the customer as we're going from monolithic to microservice or going to more of distributed architecture. It's a perception like the observability would be hard, right? What would it look like to know which component of my application is causing the bottleneck? Where is the performance issues? How do I know if I make a change what impact would I see? Like how do I see the whole system together when they're all multiple services working all together, right? So that's exactly what we use as an X-ray for. So let's go into the demo for it. And here we go. So let's go into X-rays. And it's really easy to integrate an X-ray into your application. So we already have a NuGet packages that you can add to your application and just make sure your application has a permission to write to an X-ray. Once that is there, then you'll start seeing the traces. And Native AOT is, let me just select the right time here.
So getting traces, like you got to put in what, a line of code at every call or something, or
No.
I mean, how many lines of code do I need?
Well, essentially just 2 lines of code, right? The first thing is essentially adding a NuGet package, and then you have to make sure your CloudFormation has a permission to send traces to your X-rays, right? Once that is there, then you will start looking at all the traces coming out for your application, right? And as we talked about the architecture diagram, and this is kind of representing a very similar thing, but it's more in the real time, right? That gives the flexibility of like, if you make changes to your system, you don't worry about going back and fixing the architecture diagram. It's all up to date here, right? If you come here, I can come into this one and click on, let's see if I can zoom in a little bit. And close that. Right, so here I can see the whole, the flow of how the images are being processed. The request is coming to an API gateway. How is it going to step function and how the step functions are executed. I can click on a single Lambda function and can see all the connections that this Lambda function has, right? So let's say if a developer is going to make a change to this component and I want to see what all is affected using that, this is the place to come. Like I can come into the X-ray and click on the Lambda function or click on other parts of it and see what system would I be affecting. What do I need to make sure my functionality is not affected, right? So that gives you the whole trace.
But not just that. I mean, this is a nice GUI and everything, but this is like the Ginsu knife of AWS services. There's more. It's not just that. Anybody see the Ginsu knife commercial? Come on, help me out here. There's more.
There is, and the one thing that this trace is not telling you, how long that specific step took. If I make a change, what impact that the step has, right? And this was the same thing when we go from .NET 6 to .NET 7, right? How impactful was that? So let's look into, go back to service map, click on that, and let's go into the traces. All right, so as we were uploading the photos, it's capturing these traces, right? So let's see how it looks like. I'm going to click on one of this.
So remember, at the start of this, we uploaded 2 photos. Those are the 2 different traces that you saw, the 2 uploads.
Right, so here, right from an X-ray, we can see our processing a backend took around 1.4 seconds, right? Right from an X-ray, I can see how long the backend is taking, but why is it taking 1.4 seconds, right? It should be fast. So what is the thing that's taking longer, right? So we can go deeper and look at every single method or every single function that is being triggered and see which one is taking longer, right? So if we start looking into the recognition, that's the one taking 591 milliseconds, right? That's add up to your 1.2 seconds. So right from here, I can see which function is the one that's kind of caused more latency or the cause having trouble, right? So now I want to see is, okay, it's taking longer, but why is it taking longer, right? What can I do to improve it? So I can go down and start looking into the recognition function. And here we can see, all right, recognition function took around, no, that's not the one. Here it is. In this here, it's saying 409 seconds, right? Here now you can see the recognition is taking, just talking to recognition API is taking like 377 milliseconds, right? So now, with using an X-ray, I can come down to the function that is taking the longest time, and I can also see what specific part of a function is taking longer, right? Now here we can see talking to a recognition API is taking longer because we're sending a full image to a recognition API, right? So essentially, it's just identifying what challenges you have and how you can look to optimize your function, right?
So if you think about trying to update your app 1,000 times a day or more, you're going to want to get that kind of detail back on, is it getting faster, is it getting worse, how's it respond? You don't want to wait till the call from the customer saying, hey, the app's kind of sluggish, right? So this is what you can do when you make a change to code, implement that change, what's happening? Let's get that look into it.
So just another trace that we're looking at, I was talking about the cold start versus execution, right? Using the X-ray, you can also go into that lower level of seeing what was a cold start for my function or how fast the execution happened, right? So this is another trace that the first trace I looked into, and I was looking at the same recognition function. You can see the invocation time or the initialization with the cold start is around 278 milliseconds. And then the execution took around 628 milliseconds, right? So using an X-ray, we can go deeper to that level and identify the components. And as you said, Brian, like if you make a change, I can really come into the X-ray and really see what was the impact of that, right? Did it cause a good impact? Does it cause challenges? All of that come into one place.
This is what we use to see that we had a 20 to 80% performance improvement on the cold start. This is what we use to find out we had a 200 to 400% improvement on running. So this was really helpful for us to benchmark what changes happened as we went from .NET 6 to .NET 7 with AOT.
Right. Yep. So here is the QR code that we talked about, right? Here's the time to get your cameras out. Make sure you get the source code. The whole source code is already available, so please make sure you get it.
You also will be getting a PDF, PowerPoint if you wanted of the presentation, and this will be in there, but yeah, please take the pictures of it. I mentioned at the beginning of this, I had 2 goals. So hopefully, one of the goals was, and hopefully you've gotten it, which is, can you recognize a modern app if you see one? The other goal comes later today or tonight or tomorrow. Install the code, play with it, learn from it. I'm really hoping that every developer in here will do that, and of the infrastructure hands I saw, at least half of you do that. Yeah. It's really cool and fun to play with and break and learn from.
Yeah, and learning how the best practice to use our AWS SDK, how to use the services, all of that best practices of maybe talking to DynamoDB, talking to Cognito, all of that is baked into this, right? So you can pick and choose what you want to learn from and look at this code, right?
All right, so did it work? Can you recognize a modern app? Is our app a modern app, right? If we look at these 8 characteristics, our app hits 7.5 of them.
It did, right? It also hit the front-end side of it, right? We had a Blazor UI application with Blazor Hybrid in the future that you can go across multiple platforms, or DC authentication, right? And when you start talking about backend services, it's an event-driven, scale globally. Well, scale globally.
Scale globally, right? Our front end scales globally, right, with CloudFront. Our back end scales regionally. If you didn't pick that up, if you did pick that up, you win a star. All right, please fill out your surveys. Thank you for today. And everybody who left early doesn't get this offer. If you see me out later and you give me a 5, you get a drink. Cool, thanks.
All right, thank you.